Welcome back to part 6 of our Accessible AI series. I'm Tela Mathias, one of the managing partners at PhoenixTeam, and I'm here with my good friend Brian Woodring, as usual.
Hey, Tela, thanks for having me.
As always, thank you for being here. So we've been covering how AI and generative AI technologies are going to fundamentally change how software development is done. And we've covered requirements, product design, shared understanding. We've established some qualifications through talking about how we failed in the past and what qualifies us to be able to talk about software development. And today we're going to talk about solution design. So as a career software architect, solution architect, engineer, and technology leader, set the stage for us. When we talk about solution design, solution architecture, what are we talking about?
Yeah, this one's near and dear to my heart. I spent a lot of years as a solution architect and architecture in general, and I have a great deal of love for it. To me, when we talk about the idea of shared vision, the idea that everyone working on a product or a technology system has to have a shared vision, to me, architecture is really the center of that. It is the ability to take the business needs, the non-functional needs, the functional needs, the overall solution itself, and really where the rubber meets the road. Map that to the actual systems, capabilities, components that will be required to deliver something that meets all the requirements, will allow for future scale. You're not painting yourself into a corner. I think it is one of the hardest things to do well in technology. I think it is a tremendous force multiplier when it is done well. But like a lot of other things, it is, I think we're in a little bit of a low point as an industry in terms of the effort being put into this. A lot of the modern agile philosophy of just start building and iterating. I think many people misinterpreted that. By the way, I don't think this was ever the intent of agile, but they misinterpreted that as, well, we don't really have to do architecture up front or design or requirements or a lot of other things. And so I think we're at a bit of a low point in terms of architecture as a really important force in technology. And one of the things that's been exciting to me is, can we use generative AI to kind of bring architecture back more into the mainstream of an agile iterative software development lifecycle? And I think the bad news that we're going to share a little bit here, maybe it's good news, maybe it's bad news, depending on whether you get your livelihood from architecture, is that it's not quite there yet. It's close, and like a lot of things, there's going to be some cool stuff we see, and there's going to be some rough stuff we see, and all of it's fun though. But I think we've still got a little ways to go on the architecture. What about you? I remember the very first time we met, you were really into architecture. You actually had a book that you shared with me that you were like, have you read this? And it was like, yes, obviously. Like, what is your perspective on architecture?
Yeah, O'Reilly architecture patterns, still have it right on my shelf. Mm-hmm. I've spent my entire life in software development in some form or fashion, and I am not an engineer by background. I am a math major. I did have to write some code many years ago. You probably wouldn't want to use it. It's not where I'm at, but I do very much value, especially in the tech product space. The only person you need, this is a little bit blasphemous, but the only person you really need at the end of the day to make a piece of software is a software developer, a qualified software engineer. Everybody else is very useful, but ultimately at the end of the day, where the rubber meets the road is that software engineer. And what I've seen, my experience is, we over-index, we under-index. You can look at things like the SAFe model and the concept of the architecture runway, which I'm not sure I hate. I'm not sure I hate that concept. Unlike my feelings around, some of these large-scale methodologies that are really effective.
Unlike, say, the rest of SAFe.
Yeah, unlike, say, the rest of SAFe, I'm not going to lie. And I've got all the creds, right? I'm an SPC and POP. I got them all, right?
Yeah.
And so,
we tried them all.
We've tried them all, and
they're all the worst way to make software, except all the other ways.
Except all the others. Thank you for that. And I'm not sure I hate the concept of the architecture runway, because it requires you to think about how you might want to design, how you want to implement specific use cases within the platform or the framework that you have. And I don't hate that, because the alternative, as you mentioned, is good design emerges. And I will say that definitively, no, it does not. I've never seen that work. And
That's really hope as a strategy.
I hate to say it, and whereas in life and in matters of existential and spiritual areas where hope is very much a strategy, I find that in software development, hope is definitely not a strategy.
No,
no. And so my perspective too is that we get a lot of confusion around the difference between an application architect and a solution architect. A lot of times when I talk about a solution architect, I kind of get people scratching their heads. How would you characterize the difference there, or would you characterize the difference?
Yeah, I think there is a very useful, to me, the solution architect is really at the center of the business functionality and the technical requirements to deliver a really well architected solution to a problem. So, one of the reasons maybe you don't necessarily come from an engineering background, but one of the things that probably draws you to solution architecture is there's so much of the business and the actual problem that you're solving represented there. To me, it is if done well, and we have all been on projects and products that were well architected and ones that were either poorly architected or not really architected at all, it can make a tremendous difference in your speed to deliver and the quality of what you deliver. And it can solve so many problems you're going to have down the road before you ever even have them, because it contemplates the future scalability of the system, the future growth, the ability to make it maintainable. And really what it fundamentally does is it makes it simpler. If you're doing it right, solution architecture is the art of figuring out the simplest solution for the actual problem that you're having. I think it can be an incredible multiplier. And because it is difficult and a rare skill and not often practiced these days, one of the things I'm most excited about is it something we can use AI to help us with? Because the world needs simpler software.
Yeah, and as you've a little bit spoiler alerted, maybe yes, maybe no. So
Yeah.
I had a couple of things I was trying to do, and again, I'm not a solution architect. I'm not even a software engineer, although I could impersonate one. And frankly, given time, I could do it. I know that I could do it, but I'm not, and I haven't. So what I started with in this experiment. And let me see if my image isn't popping here. So let me see if I can get it to pop. Apparently I cannot. All right, that's not good. We'll have to edit this out.
Mm-hmm. Yeah, okay. We'll see if edit. Oh, there we go.
So here's an experiment that I tried to run in the solution architecture space. So this I mentioned in our part 4, the problem of requirements. I talked about a traditional declarative software requirement specification that one of my other managing partners, Tanya Brennan, and I sat in when we were federal employees working at the Loan Guarantee Service. We sat in a room for 2 weeks and we wrote this declarative software requirement specification. And it had one picture in it. And this is the picture that it had, which is a very traditional homage, shout out to Carl Wiegers, straight out of Software Requirements 3.0. Seminal work, still a must read for anybody out there, although it is a bit dated. I still use it. I've got all the versions on my shelf here. And so this is a very traditional context diagram. And I said, hey, tell me what this shows, right? So this treats the system as a black box. It shows the major actors, major inputs. Tell me what it says. And it's okay. It misses things that are online. So it can read documents, but unlike what we saw with my lo-fis that were really well organized and were very linear, top to bottom, left to right, it gets confused. It's not bad. It doesn't get the stuff that's on the lines. So I don't know. It's not a home run. All right. So you seem to be missing some lines. Can you interpret these diagonal lines? And I pretty much struck out here. It's basically telling me there are lines and what a line might represent. So not so great.
No.
So I would say this one's kind of a dud. Brian, what do you think?
It's one of those things. It's kind of impressive. I love that it's polite when it makes a mistake. You gotta, that's better than half the engineers I've ever worked with. But Yeah, look, looking at that, I don't see anything that I couldn't understand from just looking at the diagram in about 2 minutes. And, the funny thing, of course, is I was actually the engineer who had to read that diagram many years ago and build that system. And it was extremely helpful for what it's worth. So thank you for that. But
Hey,
yeah, looking at this, yeah, if you needed to just fill out some text, great. But I don't see any real insight in here that wasn't already in the diagram.
yeah, I'm not jumping out of my chair for that one, but I didn't give up because if anything, I'm real persistent. So then I said, all right, so we struck out on the picture. So let me try going from features to solution architecture. Let me try going from words because we do great with words. And let me just drop in a set of features. I'd like to produce a business architecture visualization for a system that does a thing. Take a look and produce a diagram. And so I cut and paste from my handy dandy software requirement specification circa 2006, which is always a trip down memory lane.
So this is
Here it
really
is.
the inverse of the previous example.
Correct.
So in this case, you have narrative, you have text describing a system, and you're asking it to generate the architecture diagrams from this.
Yep. And it starts out feeling optimistic. It's optimistic. Okay. All right. Sure. We got some, yeah, okay. Not
As always, tends to do pretty strong on text.
Yeah, it's not telling me anything I didn't know. But it summarized it. So hey, I'm okay with that. All right, here we go. Oh, Brian. Yeah. Not very good. Let me see if I can zoom in here, which I should know how to do.
It's got an avant-garde quality to it that I admire. I wouldn't say that it's the easiest to understand diagram that I've ever seen. It's funny, we just mentioned that architecture's job is to make things simpler. I don't know that we're achieving that here.
I don't think we meant
Yeah,
quite
I'm
this.
not feeling like solution architecture as a profession's going anywhere because
Yeah,
of AI, at least anytime soon.
yeah. So, and look, I'm not super sophisticated. These are fun little experiments. If I spent days or weeks trying to figure something out, and I do have some areas where we have seen gains, but, I asked it to try again, slightly better. Still, I'm going to say that I kind of struck out on this one, Brian. I don't know about you. What do you think?
I would say maybe there's a little bit of value helping. Maybe it could give you some significant progress, and now you could go in and beautify it. Certainly, you probably can't take this output and really use it for anything. That's for sure. I think if you screenshotted that and put it in Jira or whatever your work system of choice is, I don't think the engineers would get a lot out of looking at that. That would be my generous interpretation, is that it probably hasn't added a ton of value that wasn't just in the narrative you'd already written.
So I would say that's strike two. So then I went a different route. I am a credentialed member of MISMO, as are all the folks on my AI team from a product perspective. And so I've loaded in my custom GPT under my PhoenixTeam proprietary instance of our Pinecone vector database. I loaded all the MISMO materials. So I decided to let me try something else. Again, ever hopeful, ever hopeful. I said, hey.
So real quick, for those who are listening who are not maybe mortgage industry experts, MISMO's a lot of things, but in this context, it's really a schema for data sets of mortgage loan data about the borrower, the loan itself, et cetera. So there's an XML schema, and you can build a lot of things around. Most of our industry is built around MISMO.
That's right. And it's very data centric, as you already pointed out. So I loaded in a whole bunch of materials into my Pinecone database. We did, and I said, "Hey, all right, let me see if you're even reading this." And so this is now in my Phoenix Burst custom GPT. So this has been designed to do very specific things, and it has a specialized set of a knowledge base that's within it. This is the RAGBot part of when I've talked about building a RAGBot. So basically, this is a RAGBot, contextualizing requests with additional information that may not be in the public domain, or that is, membership walled, paywalled. and then being able to contextualize responses. So I said, hey, give me a sample JSON snippet for a loan in MISMO 3.3. Now I know MISMO 3.3 pretty well. I'm not a guru, but I know it pretty well. And I can tell, yep, you're right. So then I said, hey, because this is not information that's generally out there. What is in a rent roll package according to MISMO? Boom. Perfect. All right, give me the JSON. Boom. Perfect.
Yeah.
It's just perfect.
Not only is it schema correct, but it's got plausible example data in it as well.
It does.
Yeah.
And so I could go on and on with this one. We started to really see a lot of interesting things once we get into the more technical artifacts of software development construction itself. One thing that I think we know is pervasive out there is I can read a legacy code base. I can convert that into, I can replicate that functionality in a modern language on a modern stack in the cloud. We're seeing that happen. Now, that's not going to improve anything about your application, with the exception of the material improvements you might see in performance gains and things like that. We know that can be done. There's a lot of investment in there. I'm assuming you've got experience with using kind of code gen or using Gen AI to migrate code bases to the cloud.
There is so there is this aspect when you own these legacy systems in a large enterprise, COBOL, Progress, mainframe type systems, things say before the 2000s or even the 90s. You end up spending a lot of time what I call architectural archaeology, where you're really just you have people, analysts, engineers who really are just spending time understanding all of the rules and logic embedded in the code that really isn't understood anywhere else in the world. The ability for generative AI models to do that in an automated fashion is fairly spectacular. And then to your point, reverse engineering that. So once you've got it pulled out into meaning, like a semantic meaning, then reverse engineering that and actually building code in a different language. That's pretty remarkable. To your point about generating schemas, databases, I had one recently where I did something similar to what you were doing, but with consumer loans instead of mortgage. Not only could it generate the JSON, I can tell you right now, it could very easily take what you did there and create a SQL schema as well, and create an entire database out of that, API endpoints. So there's a lot of that sort of plumbing and scaffolding work that goes into building software that's not really where the value is, but it just has to be done. That I think this is remarkably promising on. I think that's something we're going to go a little deeper on in a future episode too.
Yeah, agree. And I think next time maybe we can talk a little bit about the gains across the life cycle, where we think we're going to see them. One of our hypotheses is that if you have an existing piece of technology, and you can inform AI, Gen AI with that code base, and you have a high quality set of requirements that we've been able to curate. This was another one of our use cases for our custom GPT, and is also within the product we're building right now. So if I have that existing code base, if I have a set of requirements that I want to put into that code base, what does it take to push button get software? And what we've seen is it's very difficult to just go from requirements to push button get software and skip all the middle parts, which is one of the things we wanted to talk about here. What we have seen, however, is if you have an elite level solution architect in the mix who can look at those requirements that can be augmented through Gen AI, and who can define the list of services required to implement those requirements, just define them. What we have seen is Gen AI can fill them out, and it can fill them out really well. And that is magic. That's going to blow the cover off the baseball here, because I can get to high quality requirements really fast, especially if I have an existing code base then, and I know how to implement those requirements in a service. Boom, I can maybe push button get software. What do you think about that, Brian?
I think it's right there. And look, as an added benefit, the types of work that it's really good at automating are the types no one wants to do anyway. It's rote work. It's not very fun. It's not extremely creative, but it's very necessary. And if it can be automated, you can speed up the entire life cycle.
I think that's a great place to end for today. We've been talking in our Accessible AI series about solution architecture, implementation architecture, and how Gen AI has some ways to go, but there are some very clever knock your socks off type things that we are seeing and that we're going to continue to see. I am Tela Mathias, as always, here with my good friend Brian Woodring.
Thanks, everyone.
Thanks so much for joining. Please tune in next time where we'll talk about gains across the software development lifecycle. Thanks for joining.